Today's problem is asking us to make a frequency distribution chart using 5 classes. We have the table on the right, and using that table of data, we want to count the frequency for each of the classes. We want to calculate a midpoint, the relative frequencies, the cumulative frequencies, and we also want to make some graphs. So the first thing we want to do is find the smallest data value, which is 0, the largest data value, which is 29, and we're going to find the class width. Class width is the largest value minus the smallest value divided by the number of classes. So that gives us a value of 5.8 decimally. We round that to the next largest whole number, which is 6. So we want to have a class width of 6, starting with 0. We keep on adding 6 to get the beginning of each class. So 6, 12, 18, 24, and 30. The end of each class is one less than the beginning of the next class. So if the next class starts with 6, the end of the first class is 5, and we can then add 6 to each of these. So 11, 17, 23, 29, and 35. So we now have our 5 classes. We now want to find out how much data falls within each class. Going over here, the first piece of data is 18. It fits into this class. Make a tick mark. 28 fits into this class. 5 fits into the first class. 29 into this class. 22 into this class. We do this for all of the data. And now we have the number of data values that fall within each class. Notice the first class here has 8 data values, and the second class has 1 data value. If we add these up, we add 8 plus 1 plus 3 plus 5 plus 3 plus 0. The sum, sigma, of the frequencies is 20, which is the number of data values. We now would like to find the midpoint of each class. To find the midpoint of each class, add the beginning value and the end value. 0 plus 5 would be 5, divided by 2. The midpoint is 2.5. If we take the second class, the beginning value is 6, the ending value is 11. 6 plus 11 is 17. Divide that by 2 is 8.5. We then have calculated the midpoint for each class. Now we would like to know the relative frequency versus the frequency. The first class has 8 frequency values. If we divide that by the total number of frequencies, 20, 8 over 20 as a decimal is 0.4. Converted to a percent, that would be 40% of the data falls within the first class. If we take the third class, we have 3 data values. Divide that by the total, 20. 3 over 20 turns out to be 0.15 or 15%. If we add the values in this column, which is the sigma sum of f's divided by n, remember each of these is an f divided by n. So if we sum this column, it should equal 100% or 1. The last column is the cumulative frequency, not the frequency. So in the first class, we have 8 frequency values. And when we move to the next class, we're adding 1 more value. That makes that 9. And when we move to the next class, that's 3 more values. That's 12. 5 more values. That's 17. 3 more values. That's 20. And we stay at 20. So that's how we fill in the chart. Now let's use this chart to make some graphs. The first graph is a frequency histogram. And we label the vertical value as frequency and scale off the data values from a minimum to the maximum, 0 to 8. And the horizontal is the time, which is the data in minutes. And we're going to use the midpoint as the representation for each bar rather than the beginning and end of each class. So there's different ways of doing this, but I'm using the midpoint of each class rather than the beginning and the end. So the midpoint of 2.5 has a frequency of 8. So you see the height is 8. So it's a bar graph. The midpoint of 8.5 has one frequency value. So there's the height of 1. The midpoint 14.5 has a vertical height of 3, etc. And we make bars. So this is called a vertical bar graph, or a frequency histograph, as it's of frequencies. We're going to make a very similar diagram, but it's called a frequency polygon. Again, the vertical is frequency scaled off. The horizontal is the time, using the midpoints of each class as the data values. And again, at the 2.5, at the 2.5 midpoint, we have a value of 8. At the 8.5 midpoint, we have a value of 1. And at the midpoint 14.5, we have a value of 3. Now, a graph always has to start someplace. So usually one class width to the left of the smallest value would be a good starting point. And that starting point would be 0. We then connect all the dots from here to here by straight line segments. So this is a frequency polygon, often called a line graph. The next graph we want to do is a ogive graph. And it's a little different than the previous two in that the vertical is the cumulative frequency, not the frequency. Again, I scale it off appropriately. The horizontal is the time, again, in minutes of the data. At 2.5 midpoint, we have a cumulative frequency of 8. But at a 8.5 midpoint, the cumulative frequency has gone up to 9. At a midpoint of 14.5, the cumulative frequency has gone up to 12, etc. Again, you need some starting point. So when the time is 0, the cumulative frequency is 0. We connect the dots by straight line segments. And this is an ogive graph, which is a graph of the cumulative frequency rather than the frequency relative to the data. Thank you.